Dart Skill presents Shift or Shuffle. Transformation is the change in position or size of a two-dimensional shape. In this video, we are going to talk about transformations related to the change in position only, and that can happen in three different ways. Let's talk about each one of them, starting with translation. Translation. Imagine on the XY coordinate plane, so this is the x-axis, this is the y-axis. You have a point and its coordinates, let's say, is given by 2, 3. When we move this point, let's say 1 unit to the right, so let's say 1 unit to the right, and then 3 units down, 1 unit to the right, 3 units down, the new position of this point is somewhere here, and the new coordinate is given as 2 plus 1, that's 3, comma, 3 units down means 3 minus 3, which is 0. And we could actually do this to an entire shape, meaning every point on that shape. Move right, left, up or down, and that's what we call translation. So instead of that one single point, let's say we had a triangle out here. So if you were to move every point on this triangle 1 unit to the right and 3 units down, the triangle would take this position. Similarly, if you have a rectangle in the XY plane such that the coordinates of the 4 corners are, let's say, 1, 1, 1, 3, 5, 1, and 5, 3. And if you want to translate this rectangle, let's say this time 4 units to the left and 1 unit up, the new position of this point 1, 3 would be 1 minus 4 because you're going left, so that's a negative 3. So we have a negative 3 comma, and then the 3 goes up by 1, so we have negative 3 4. So it's somewhere over here, let's say negative 3 4. Similarly, this 5 3 shifts to 5 minus 4, which is 1, comma 3 plus 1, which is 4. So if I were to name these points as A, B, C, D, this is the new position of A, let's call it A prime. This is the new position of B, let's call it B prime. And then C moves on to 5 minus 4, which is 1, comma 1 plus 1, which is 2. So it's somewhere over here. And similarly, the new position for this point D is 1 minus 4, which is negative 3 again, and then 1 plus 1, which is 2. So this is C prime and this is D prime. So the whole rectangle would shift like this. And I wasn't accurate about the coordinate points, reason why you don't see these two the same size. But if you do the same thing on a graph paper, marking off the numbers, you would come to see that this rectangle and this rectangle would be exactly the same size. Translation is just about dragging or sliding a shape on the XY coordinate plane. The next type of transformation we could talk about is reflection. When a given shape is reflected, about a line, the line actually acts as a mirror, and you see the same thing on the other side of the mirror at the same distance as in front of the mirror. So if this triangle were to be reflected about this straight line, the new position would be something like this. And if that same shape were to be reflected about this line, this is how it would look like after the reflection. And if this is the x-axis and this is the y-axis, we say this is the reflection of this shape about the x-axis, and this is the reflection of this shape about the y-axis. You could reflect a shape about any straight line, which also includes its own lines of symmetry. The next type, or the third type of transformation we are going to talk about, is called rotation. Imagine you have a straight line, let's call it AB, and you want to rotate the straight line in the clockwise direction, let's say by an angle of 90 degrees, keeping the position of this point A fixed, as if you have pinned down this point A and you are trying to rotate this. So for a 90-degree clockwise rotation, this B comes down over here to B prime, such that this angle is 90 degrees or a right angle. We say that the straight line segment AB has been rotated by an angle of 90 degrees in the clockwise direction about point A. If you were to rotate the same line segment through the same angle in the same direction but about a different point, let's say B, which means B is fixed, in that case A would have moved up. So the final position actually depends on the point about which the rotation takes place. And this whole idea can be extended to any shape. Let's say we have a triangle. Let's name the vertices as A, B and C. If we want to rotate this triangle, let's say in the counterclockwise direction through an angle of 90 degrees about this point C, that means the point C remains fixed. The final position of the point C is still the same point. And the entire shape is to be rotated through an angle of 90 degrees in the anti-clockwise or the counterclockwise direction. Because the rotation is about point C will be fixed. The new position will still be the same point. So we will have this line segment BC going down 90 degrees like this. The line segment AC will come down by 90 degrees with the same length, and then the same thing happens with AB. So this is the new position of A. Let's call that A prime or A dash. This is B prime, and C prime, of course, is the same as point C. And like I said, the scaling was not right. If you did this on a graph paper with accurate measurements, these two triangles would be exactly the same size. They would be congruent.